Section 20.3, we're going to carry on from what we were talking about in the last section about Ohm's law. And remember, Ohm's law was voltage is equal to current times resistance, or V is equal to I times R. We're going to carry on and we can talk about electrical power. Now, why is electrical power crucial? Well, because power, we've talked about power in watts. Now, typically you'll see this with a 60-watt light bulb. That's how much power the white light bulb is be able to convert it to. So power is equal to current times voltage. P is equal to I times V. Remember, if we rearrange this, power is equal to I times V. So not only could we have power with machines, we now have the ability to calculate power with electrical devices and equipment to figure out how much power is going to be needed from an electrical standpoint for a device to run. So power is equal to current times voltage. Next up, we can also take power and we can figure out electrical energy. And that's the amount of energy used by an appliance over a particular amount of time. So when we throw time into this equation, energy is equal to power times time, and it's in hours. And why do we use hours? Because typically that's how we get charged for electricity. We get charged for electricity on a kilowatt hour. So that is why we typically use hours as our time instead of our standard seconds that we've used. So energy, E is equal to PT. E is energy. What's our unit for energy? It's typically joules. Power is in watts. Time is in hours. Now, I explained why it's in hours. Last thing I want to explain with section 20.3 is you'll see that typically we have kilowatt hours. Kilowatt hours is our unit for energy, and that's just the way we get charged electricity. Typically your parents get charged like 8.245 cents per kilowatt hour. All right, lots of things run on plenty of kilowatt hours, and in fact that's the little generator that you have at your house is measuring your electrical output. That's what they bill you in then, is a kilowatt hour based on how much energy you've used over time. So an extension of Ohm's law, we can figure out power used in a circuit or in an appliance or a device. And if we know power, how long is it exerting that power? We can figure out energy, because energy is equal to power times time, time in hours. So very quick section, but that will conclude with those two equations, we will conclude section 20.3.